Love that kitty.
Good morning and welcome everyone to OpenCV Weekly Webinar. I'm Dr. Satya Malik, CEO of OpenCV. This week, we are excited to have members of the first prize winner of OpenCV AI Competition 2022 Core Track, Team Recycling Rush. Welcome Edwin Salcedo and Mariel Fernandez to the show. This project uses AI and computer vision to help aquatic robots navigate and autonomously clean water bodies. It fascinated our judges and won the team $5,000. We hope you will find this project fascinating as well. But first, with me, as always, is Phil Nelson, Director of Content and Creative at OpenCV. Phil produces the show, and so if anything goes wrong, it's his fault.
That's true. Good morning, everyone. Welcome once again to OpenCV Weekly Webinar, episode 91, if you can believe that. I am the co-host with the co-most, the second banana who is second to none. I am also known as your plus one and only. It's forever if you're with me. But there's a few things we do every single week here on OpenCV Weekly Webinar, the first of which is a special giveaway to you in the audience. Stay tuned for that later in the episode. You will have a chance to win the OpenCV course of your choosing, including the upcoming OpenCV course about AI art generation with Stable Diffusion, which was just about to launch. Satya, would you like to talk about that to the folks at home before we get started today?
Yeah, so it's a very special course that we are launching. It's on Stable Diffusion. As people know, that it is Stable Diffusion is one of the foundational models that have come up in computer vision, where you can use it to generate art. You prompt something and it can generate art for you. But that's just the tip of the iceberg. You can do a lot more with Stable Diffusion, and you will know everything about that in the course. We are actually launching two courses. One is called AI art generation, and this is for everybody. People who do not have programming background, doesn't matter. And the second one is advanced AI art generation, and this is for programmers, so that we'll teach you a lot of things, including how to fine-tune your Stable Diffusion models so that you're not just prompting. You will also learn how to we will also help you train a GPT model on prompts so that the prompts can be automatic and things like that, right? We will also teach you in painting, out painting, so that you can put, things around people, outside people. We will teach you animation, and it's going to be a fascinating course. This part is, it is a short course. Each of these courses can be done over a weekend, right? So we are packing a lot of stuff into into these courses without actually inflating it. So, and of course, because one of the reasons we do the Kickstarter campaign is so that we can have the price we can have a really sweet price. And we're still not decided on the exact price, but it will be affordable to people around the world. So I'm really excited about that. And of course, being at the cutting edge of these things, Stable Diffusion, art generation, you will have a blast. You'll have a blast. While creating this course, I'm learning myself so much that I'm blown away. It's almost like I'm living in the future, right? So the things that we are seeing, every day things are changing. Every day something new is coming out, and it's just fascinating. It's mind-boggling how fast these things are moving, and I'm surprised. I'm blown away. It's not like sometimes you see a result and you say, oh, it is slightly better than before and things like that. It's obvious. Once you know how they are doing it, you say, oh, I could have done it. But with Stable Diffusion, the pace at which it is moving, the pace at which this whole industry is moving, it is just out of the world, right? So very exciting field. And one of my partners who is working on this course as well, he said that he sucked as a kid. He sucked at creating art, and now one of the art that he created was used in our promotional campaign. So he's so thrilled that he was he was a kid who had no experience with art, and now suddenly he has this superpower. So exciting times.
Yeah, it seems like the field is rapidly advancing. Like everything with AI currently, there's just so much. Like it's constant. It seems like every day there's some new big advance. Somebody in the chat mentioned we're already on YOLO 8. Like remember when YOLO 1 came out? we're already on YOLO 8. That's fascinating. It's a really interesting time to be in this industry. The other thing we're doing here this week is taking questions from you in the audience, if you didn't notice. So go ahead and use the Zoom Q&A button wherever, or in the chat system, wherever you're watching the show, on YouTube, on Twitch, on Twitter, etc. Ask your question there, and we'll do our best to answer as many as we can during the course of the show. But for now, I think that's about it. Just welcome our guests. Welcome to the show, folks. Please briefly tell the people a little bit about yourself, introduce yourself, so I have somewhere to put our little lower third for each of you on there with your name and title, and then we'll get on with the show.
Phil, one other thing, on Zoom, I'm seeing a collage of videos, not the main video.
That's odd. It should be pinned for everybody.
What about the audience? Are you seeing the studio view, or are you guys seeing the collage view?
Yeah, in Zoom here. I'm not sure. If you're not seeing the studio view, what you can do is right-click on the studio and spotlight for everyone. How's that?
Yeah.
Tell me if that fixed it for Zoom. That fixed it for everybody? Sorry about that. It's been a while since we did it this way. Man, this is going to be a fun one to edit. Let's do that. Let's do that again. Take it from the middle. So yeah, let's get started with the show. First, our guests, please go ahead and introduce yourselves and let everybody out there know who you are, and then we'll get started with your presentation about this incredible aquatic recycling project.
Okay, thank you. My name is Mariel Fernandez. I am a mechatronics engineer student at Universidad Católica Boliviana. I was in charge of the hardware part in this project.
Awesome. Welcome.
My name is Edwin Salcedo. I work as a lecturer and research engineer at the Bolivian Catholic University, the same university as Mariel, and I was in charge of all the software components, the models, the software side. We are a recycling rush team, and we are 3 members, Mariel, Yamil, and I. We worked on this project, Aquatic Recycling, via Autonomous Duckweed Collection in Lake Titicaca. We started in the beginning of September, and I'm going to introduce the problem, but before that, I would like to thank you for having us here, and also for organizing the competition. I think it was a big motivation for us to develop this project, and also to improve our skills, to learn more. It was amazing.
Awesome.
That's great.
Okay, so I will start with an introduction about what is duckweed. This is a plant that grows over the surface of water bodies, such as lakes or lagoons. And when it overgrows, it covers all the light from the sunlight, and biodiversity inside the water starts declining, and then you notice that there are less and less fish, and there are also other problems related to duckweed. But this happens frequently in Lake Titicaca, in lakes and lagoons here in Bolivia, and I'm sure that you have also seen this kind of effect in other countries. It's common. So we wanted to attack this problem, how we would collect or monitor an area with a robot and computer vision. And that's why we aim to develop a solution for this. I'll pass the word to Mariel now.
Thank you. Okay, as I said before, I was in charge of the hardware part. So I'm going to explain something about the process of the design and the challenges we faced during this process. When I'm planning this project, we have a clear idea in mind from a hardware point of view. So we had to develop a floating mobile robot, which had to be capable of collecting duckweed. But how to achieve this and how to make a robot float on the water. These were some of the
Were
challenges we
there
faced.
were there any design constraints around size and weight, or that was as long as it floated didn't matter?
Excuse me?
Did you have any design constraints for weight of the device and the size, or it did not matter?
Well, we thought many things. Uh, we wanted to make this prototype big, but first of all, we had to make a prototype that could be um, tiny. Its size is um, half a meter, so
Okay.
it, it we focused on the we focused on making a prototype.
Okay.
So well, that's it.
All right.
I would like to comment something about that. We had also economic constraint because the
Right.
device will be bigger. It was a lot of material to print it, and we also considered other materials. So that was a main constraint.
Exactly.
Okay.
Okay. So um, having these ideas in mind, these were some of the first prototypes that we designed in CAD design software, which was SolidWorks. Well, this was the first design we worked with, the first idea, the first image that's on the screen. So we took this design as a basis for the development of the vehicle. Well, obviously it's a very simple design, but that was the basis. So we needed to include floats to achieve buoyancy, and in addition, we also had to think about how to place the electronics efficiently, and how to make the necessary connections, and that's why we added this box at the top of the vehicle. That's where the electronic parts are in. Uh, well, Next slide, please. Well,
This slide animations are fancy. I'm impressed.
thank you. Yes, that's our design in SolidWorks. During this process, we experimented with different ideas and concepts, but in the end, we came up with this final design that you can see in the screen. As you can see, we have two flotation devices and a box housing the electronic components. Also, we have a structure at the back to house the net where we could collect the duckweed. Okay, now I'm going to explain the manufacturing and assembly. Well, for manufacturing and assembly for this aquatic vehicle, we chose 3D printing because of the we know that many prototypes are well designed and printed in 3D, so we chose this option, and we used PLA material because of its easy printing and also uh, well um, to guarantee the integrity and solidity of the structure, we used bolts and epoxy glue. And well, in these images, you can see how was the process of uh, fitting the parts together. And also, I like to say that it was important to make some tests of stability um, to perform, um, to verify a correct buoyancy of the vehicle. Also, we added some weights because at the first time these these floats were a little too big, so we
Did
had
you
to
ever
add weights.
lose? Did you ever lose any
Well,
electronics because of the boat capsized or something? Boat overturned? Did you ever face that?
Yeah, do you have any tales of waterlogged circuit boards? Because the people love those.
exactly. Well, fortunately, we did not have any of
That's great.
these problems because we, well, first of all, we made the tests in water. We did not put any electronic components or made something dangerous for the components.
Right.
So uh, fortunately, we did not have. But well,
That's great.
in in the control part, we had some. Um, well, we burned a cable, so some some things that can happen during the testing part.
Right.
Okay, well, um, we made this test, yeah. Okay, now I'm going to explain something about the control part. Well, we have the floating part, and we already have a device, a vehicle that could float in the water, but we needed the motion. So also we needed to control this feature, and to achieve this, we used two motors, as you can see in this diagram. And we control these motors by using a microcontroller. We implemented the use of PWM pins to send speed signals and GPIO pins also to control the direction of rotation of the motors, uh, allowing the vehicle to move forward, backward, left, and right. So we to control these movements and perform the tests, we used a remote control and a joystick which sent a signal through an XB module. Um, well, as you can see in the diagram, for the XB module, we use RxTX communication, and to send signals from the Jetson Nano to the microcontroller, we use I2C communication. Okay, now we're going to see a video from the testing part. Well, we needed it to make sure that everything was working properly before put this device into the water. So we mainly tested the motors and connections to check that they did not have any problems. And well, here is a test out of the water, of course, to see that the motors move correctly and to the right side, because if any motor moved in the opposite direction, well, it could change everything. And well, that was
Yeah,
something that
it's interesting because you kind of it seems like water is a lot different than land, right? Like the thing is floating like almost in space, and so the forces that you use to make these things move is a lot different than a terrestrial robot.
Right.
exactly. So, well, why we made testing out of the water. Thank you.
Okay.
Okay.
Thank you, Mariel. I will continue from this part. The software side was actually supported by an steering angle prediction model. So we actually combined two models, a duckweed detector and also a steering angle classifier. And both of them were receiving an input from the camera, something like this. And both of them were processing the image. And this model actually helped us to detect samples of duckweed, and this one was mainly for detecting the correct angle for the vehicle. So below you can see some samples of images and the final angle that we are getting from the models. As you can see, we were combining the inference, and we also included a weight for each of them. And I'm going to explain how we worked with both models because it was a lot of data collection work.
Yeah.
In the
Yeah,
case
and
of
similarly to what I was saying a moment ago about how different these are, I feel like there's probably a lot fewer resources available for aquatic robots versus, bipedal or tank tread or quadruped land robots. And so you probably had to do a lot more of your original work here than people might realize.
Yeah.
exactly, we had to collect our own data because there is no data of this kind of environment. And also from Titicaca Lake, we couldn't find images similar to the area where we were working, and
Ah.
that's why. Sorry.
No, no. I can see where you're going, so it's impressive.
Thank you. Then we decided to implement an environment with Unity and Blender, and we developed a simulation environment which would help us to collect data, the images for the steering angle classification. So we focus on replicating an environment that was very similar to the real environment and the Titicaca Lake, and that's why we also designed the boats similar to the boats in Titicaca Lake. What you are seeing on the bottom is a duckweed. It's our attempt to represent duckweed, but that was very difficult to do because it's not something that has a common pattern. Sometimes duckweed has cumulus in different positions, locations, but this was the environment that helped us to collect data. And in the beginning, we planned to collect data, thinking of 4 types of trips. The first one would be a trip that is straight. The second one would be maybe a trip turning left, turning right. Also trips along bushes, along boats, along a plant named Totora as well, that is present in Titicaca Lake. And we noticed that after doing exploratory data analysis, that our data set was unbalanced. And when we tried to train our model with this data set, the model was always saying to the vehicle, you have to move to the right. You have to move to the right all the time. So
So you had
that was
So,
a right bias on the data set.
yeah.
could you explain what we are looking at here? What do the graphs represent?
Yeah. Here we are seeing in the horizontal axis the the angle, the angles. So it's
Okay,
from less 120 to plus positive 120,
G-
and
got it.
we are seeing frequencies as well here.
Yeah.
So in total, we had 15,000
Hmm.
images, and then we noticed that
Right.
we had problems with this distribution, and
Right.
we worked on the documentation using OpenCV methods, and also we tried to implement weather-based augmentations, and
Uh huh.
we achieved this distribution that we noticed that it was working nicely with
Yeah.
with the model. It was well distributed, and in the end, we collected 60,000 images. Okay, so that was about the starting angle classification. Something that I would like to also mention about that model is that in the beginning we were trying to work on starting angle prediction. I mean,
Hmm.
trying to detect a specific value, but then we noticed that in an aquatic environment, the angle it doesn't vary too much as in a terrestrial environment. Uh, as you notice, it's very different because when you are working with self-driving cars, you have to predict the steering angle all the time,
Right.
frame per frame. But in this case, classification was enough just to tell us how the robot should move. So the next model that helped us a lot for duckweed detection, and in consequence for uh, the next movement of the vehicle was duckweed detection. I mean, based on object detection.
Hmm.
And this model was quite challenging because we didn't find data sets, so we had to collect our own data set. Our main source was Google Images, and we scrapped images from that source. We we collected this number, 4,000 images. Uh, we got this number, but then we noticed that the number was not good because a lot of samples were having um, other kinds of images, drawings,
Right.
other plots. So that's why we filtered all those images, and then we managed to get 3,000, something like that. But
Hmm.
then we continued labeling the dataset using RoboFlow, and
Right.
we divided the task between, I mean, among the members of the team, and that was also an iterative process. But in the end, we noticed that still the model wasn't good detecting duckweed. It was very challenging. It was misdetecting some plants as duckweed. That's why
Hmm.
we worked in this kind of filtering. We classified all these instances um, into these categories: wide, empty, close, near wide, near close. All of them are related to the perspective of the camera. So
Mm.
it's about the distance between the camera and duckweed. And we
Right.
noticed that with close and near close, we we started getting fascinating results. So we discarded other categories, one wide
Mm.
and empty. We kept empty because it was important for the detection task.
Got it.
Well, this is a video with the model with partial results. Actually, our final results are a bit better, but
Hmm.
it's detecting duckweed, cumulus of duckweed, and that's important for our model because when we detect duckweed, the vehicle decides to go to that side in order to collect. duckweed.
Yeah, I think people maybe who haven't done many data projects themselves might underestimate just how complicated it is to accurately detect these kind of organic shapes that they're not uniform. You know, nature doesn't build things the same shape every time. There's a little bit of
Right.
variance, and they, especially with things like this duckweed, they also will, you know, join together in different shapes, and you need to know that contiguous chunk of duckweed, and so it's very yeah, so it's a hard problem.
Yeah, totally. In the beginning, we also thought of segmentation, processing, trying to detect leaf by leaf, but it
Yeah.
wasn't a good idea. And yeah, we
Was it
were,
was it not a good idea because it was too much work? Because segmentation model, obviously, you will have to segment every little thing, so that's very tedious to do. Is that the reason you did not choose the segmentation model?
that's
Or
true. That was,
okay,
sorry, that was one of the reasons.
yeah,
Another reason was that um, there are some leaves that are similar to duckweed. And
oh,
when we try to implement, for example, just segmentation with OpenCV,
mm-hmm.
those leaves, I mean, those plants were also being classified, or I mean, segmented as duckweed.
Got
So
it.
that was a problem.
Right. And segmentation models typically are slower. It's a more expensive process. And if you don't need it, you can get away with, you know, object detection in a lot of cases. Yeah.
Thank you. And okay, so about the evaluation metrics, we have evaluation for the storing angle classification. These are our metrics. I can say that we still have room uh, to improve because we have to test more our vehicle. I would like to show you uh, the precision of the robot itself, but
Yeah.
it requires more testing. But for the duckweed detection, it was astonishing to get these results. I noticed that all the process of improving the data had a lot of
Mm-hmm.
effect on the results. In the beginning, we got regular results, and
Mm-hmm.
then we noticed that classifying per distance each sample
Mm-hmm.
was a good way to improve our results.
Right. I mean, I keep saying that, most of the time people who are new to the field, they think that, oh, they'll try a new architecture, they'll try this and that. But ultimately, the best bang for the buck you get is by looking at the data and seeing how you can improve the data one way or the other, right? Sometimes you have to filter out some things. Sometimes you will notice glaring mistakes in your data. So the very first thing, changing the architecture, if you're using for object detection, for example, if you're using YOLO v5 versus YOLO v8, doesn't matter much, right? If you're not getting good results, the very first thing to do is not to change the architecture, because changing the architecture would give you maybe a 1% improvement in your final result, right? You change the architecture if you're in a contest, right? You're trying to win, you're trying to get that last half percentage improvement over others. But if your thing doesn't work, right? If you're doing an object detection thing and your map is very small, then you don't go and change the architecture. You first figure out what is the problem, and usually it is the data where the problem lies, and that's the first thing you should do. Not, uh, you know, not try to change different architectures. It's usually the data. So, uh, actually, there is a whole this field called data-driven AI or a data-centric AI, where the whole focus is that don't worry about the architecture, as long as it is overfitting on the training set, you will be fine. All the effort should be should go in looking at the data, trying to find various ways it can be, various ways in which you can massage it, filter it, remove stuff for it. You can also figure out which parts of the data your algorithm is not working well on, and things like that. That will give you the biggest bang for the buck. And we are talking about 10% improvement and things like that, not just 0.5%.
That's true. We experienced that in this project because in the beginning with the data, we weren't getting good results. But I can say that we invested like 2 or 3 weeks improving the data, these data sets. It was a lot of work in order to improve the data, and it was important because just improving the models or changing the models for something more sophisticated wouldn't have that effect on the result.
Yeah, I have this story about Davis King, who wrote DLib. So a few years back, DLib had one of the best implementations of facial landmark detection. And we got the same implementation, the same algorithm implemented in OpenCV as well. And we trained a model, and it was not close to DLib's model, right? So I talked to Davis King, and I said, what's going on? How did you train the model, right? On our side, on OpenCV side, this thing was given to an intern. So the intern was doing all the work. Davis told me that, he sat down, he did his own data annotation. And I said, what do you mean? Like, that's a lot of work, right? If you want to, at that time, 2,000 images for facial landmark detection was quite a lot, because 2,000 images times 68 points. And he said that he went through all of it. He spent 2 or 3 days. Just imagine, 24 hours, 40 hours. He's sitting there with his headphones on. He said that I was just listening to some audiobook, and this is all he did. Just imagine, right? You would think that, some people who are at the top of their game, they don't spend time, data annotating their data. No, he did it, right? So he did that even for facial. At one point, the face recognition on DLib was pretty close to the state of the art. And this is one guy doing all the work, right? And he came up with all these mechanisms on how to clean up his data, right? By clustering and all those things. And all the effort, right? You would think that, what is the secret sauce behind what algorithm he's using? We were both implementing the same algorithm, OpenCV and DLib. Why were his results better than ours, right? And it ultimately boiled down to that he really cared. He really cared about everything that went into his training set. And he would spend days fixing his data. And you cannot compete with somebody who is so disciplined in doing that kind of grunt work, right?
Yeah,
So,
sometimes all there is to do is just sit down and do the work, the tedious task. Like sometimes you just have to read all the papers.
right,
definitely.
Totally agree. Well, and this was the last slide, actually. We want to thank you once again for organizing the competition. This is the device navigating in a water body, and
so cool.
Yeah, it's quite fascinating how the vehicle can just float. That was astonishing, and then the results are amazing. I think actually these results motivate us to continue the project, and
it's great.
We aim to continue researching how to improve the mapping, the localization of the vehicle, but we are also working with ROS framework to map all the regions around the vehicle and understand better how this robot could move.
So some aquatic SLAM is what you're talking about. Maybe using ROS.
Yeah.
Very cool.
That's great.
Now.
Yeah, it's exciting. Thanks so much. What an awesome presentation and what an awesome project. Congratulations again for being our first place winners for OpenCV AI Competition 2022. Well deserved, as far as I'm concerned.
Yeah, I
Very
always
much.
have very high respect for people who do something physical,
Yeah.
right? Not, I mean, I have people who do programming, but it is a different level of respect, right? People
Yeah.
who actually build something in the world physical and you're using vision. So that's because it's a lot of work, right? People don't
It
realize
is.
that software projects you can do a lot in a very short period of time, but when you even if you add one hardware, the just complexity explodes, right? There are so many little things that go wrong with hardware. So amazing effort, and congratulations again.
Yeah, absolutely. Yeah, congratulations to both of you. So yeah, we've got about 10 minutes left here for questions, but first I think we should do our giveaway. Let me give myself the fill cam here.
Can I also have one more announcement about the
Yeah.
about the stable diffusion?
Yeah, man,
So
just
the
look
Kickstarter
at the camera.
campaign. So the Kickstarter campaign we are doing for stable diffusion model, we also have a little competition going on there. And Phil, if you could share that link for
Yes.
our competition. The idea is that you use any available, publicly available model or even tool which is not open source. It doesn't matter. Any AI tool you use, which is prompt based, so you prompt and you create an image, and that image should be in this. The theme is love, science, and art, right? Because we are going to launch this thing on February 14. And if we use your image, we are going to give you an iPad Air. So please, there is a form that you need to fill out. You have to submit the image, publish it on social media with a specific hashtag, and then also share the prompt with us so that we can reproduce the image. And if you do all of those things, you get a chance. If we actually select your image, then we will definitely, you'll win an iPad Air. So that's one little contest going on.
Yeah, that's awesome. I also I personally use an iPad Air all the time. It's a great piece of hardware to. It's basically replaced a laptop for me. If I'm going out to lunch somewhere and I want to do a little bit of work at lunch, I'll just throw my iPad in my bag and go instead of having to worry about my whole dang computer. So yeah, I just dropped the link in the chat and everywhere. We'll also have it in the show notes here. So. Even if you're watching this next week, it should still be up. What's the deadline for that, Satya?
I think it's in the page. I cannot
Yeah,
remember
let
off
me
the
double
top of
check.
my head, but it is probably February 12th, end of the day, Pacific time.
Yes, the deadline is midnight Pacific time, February 12th. The winner announcement is supposed to be on the 14th of February.
Yeah.
So, yeah, good luck out there to everybody that joins. We hope to see some really cool looking AI art. Yeah, let's do our giveaway here. So if this is the first time you've joined us for OpenCV Weekly, or if you just need a little reminder, one of the things we do every single week on this show is give away something to you in the audience for free. This week we'll be giving away the OpenCV course of your choosing to our trivia winner. You can go to opencv.org/courses to see what courses are available. Maybe buy one for yourself, maybe buy one for a friend. Invest in your education or the education of a loved one in the new year. You'll have a chance to win one here, though, by answering our trivia question. The first person to answer the question I ask in our Zoom chat will win the OpenCV course of their choosing. Please, if you have won in the last few months, don't answer and give somebody else a chance to win. So get ready to answer in the chat now, all of you there in the audience. Earlier in the show, our guests talked about one of the tools they used, our good friends at RoboFlow. They also mentioned they filtered and scrapped a certain number of images. How many images did they scrap?
That's a brutal one. I mean, people obviously remember approximately.
Oh man, they're getting close. Yeah, they're getting close. See, some of these folks get in my head, and I gotta throw them a curveball every now and again. We're getting some wackadoo answers here. I think I finally got them this time. I might have to ask a different trivia question. I'll give you all 5 more seconds. So nobody got it yet. All right, we'll oh shit, wait, somebody got it. Yes, Stefan, congratulations, Stefan. The answer was 4,351 scrapped images. Congratulations, Stefan. Sarnev, please send one email to phil@opencv.org with the course you would like, including, if you want, you can pick the upcoming AI one. What's that? Yes, Andrea, one of our trivia sharks, says for I in range, and in parentheses 1,000 or 19,200. Well done. Once we get our merch store stood up, I'll start giving out stickers for making us laugh on the show. If you make Satya break, you get a sticker. That's going to be the new rule.
Right.
So congratulations, Stefan. Please send one email to phil@opencv.org. So we've got some great questions for folks here in the chat and on our various other services. We've got time for just a few of them. I'm going to pick a few from Zoom here. Let's see here. Bruce Kahn would like to know, did the time of day affect the accuracy of detecting the duckweed due to the changing angle of the sun and different, the different light that will be cast on things based on what time of day it is?
That's a good question. Actually, we just tested the robot at a certain time. We didn't test it at different times, so we didn't have light variation.
Yeah, and even everywhere, it can be a red nighttime sunset. It can be very orange. It can be very blue. I wonder if that would affect the detection as well. That's a great question from Bruce there.
Yeah, it certainly would. The thing is that for competitions, we expect a proof of concept implementation, right?
Yeah.
So which is perfect in this case. But if you want to productize this thing, then that's a completely different ball game, right? It's 80% of the work is still left if you want to go from proof of concept to productization.
Yeah.
Yeah.
Bhaskar would like to know, did glare from the water affect duckweed detections? Or did you notice anything just from, similar to the previous question, just from glare on the surface of the water? Did you have issues with that?
During the testing time, we noticed that the weather, it was a big constraint. We noticed that the robot was designed to be deployed in calm weather, but as you could see in the video, the weather wasn't calm, and the water was just affecting the navigation. That was a big problem for the robot.
Yeah, I can imagine. Like Satya said, I think and a lot of this is just data. To keep this project moving, I think your next big steps are just going to be collecting a metric tons more photos and throwing away most of them. And maybe a question for me is, did you all use any data augmentation tools for this? Like even just like rotating or mirroring your collected images to improve the accuracy in different situations?
For the steering angle detection, we applied OpenCV mainly for data augmentation, and we also tried to implement some glare to improve that problem. But still, I noticed that when the environment is changing a lot, it requires more time to test.
Makes sense. Yeah, definitely. Jorge would like to know what kind of compute resources are required for the current version of the robot?
Okay. we're mainly using a Jetson development kit, and in it we are using Ubuntu-based system. So inside we are installing mainly Python and other libraries, OpenCV, PyTorch. That is,
Yeah.
I think, the base of our project.
Is it a Jetson NX or which kind of?
Sorry?
What kind of Jetson is it? Is it an NX device?
Yeah, it's the Jetson development kit. I think it's the second version, just of 2 gigabytes.
Cool.
Okay.
Yeah, so that's not bad at all. Do you? Someone else was asking. Do you roughly know what the cost was for putting together the, if you were going to build a second one of these, what do you expect it would cost hardware wise?
That's an interesting question to answer, because in the end, we noticed that the total cost was $700. But yeah, it was mainly because of the 3D printing material. And we did we developed the project with 3D printing because other materials were even more expensive. For example, metal or wood. We thought of those materials as well, and PLA was more viable.
That makes sense. Yeah, surprisingly versatile as a material, PLA. I have a Creality 3D printer here that I use often, and it's I'm always surprised. I have been lately experimenting with 3D printing some little saucers for my potted plants, so they don't leak on my countertops if I overwater them, which happens sometimes. But it works great for that. It'll last for quite a while. Yeah. So Mario's telling me it's 10 o'clock. I think before we call it a day, let's give the people what they want. Damn it, for once. The cat cam. Cat's back. The cat's back, everybody. Say hello to our fine feline friend who is, as of yet, tragically unnamed. If you have an idea for a name for our beloved studio cat, please send your suggestions to newsletter@opencv.org. We will read the best suggestions here on the air next week, and just bask in the glory of our dear friend for just a moment here. Maybe we'll maybe we'll finally hear the cat talk next week. I don't know. It'll maybe meow at us. Maybe that's how I can get people to kind of speed up. It's like the speed up noise. It's a cat meow. We'll look into that. It's possible. It's something we might do.
That would be some cat GPT.
Wow. All right, we're calling it a day on that one. You know what? We're not going to top that today. Thanks so much to our guests, and congratulations once again. Satya, you want to take us home?
Thank you so much, Edwin and Mariel, for being here, for participating in the contest, and making this competition series a great success. And I also want to thank Phil for organizing the show, as always. And things went very smoothly today, so none of it is your fault. Thank you, our audience. I hope that you support us for this Stable Diffusion Kickstarter campaign. I'm very excited about it, and I hope that you will support us just like you have done in several other Kickstarter campaigns. And I really feel that the thing that we are putting together, it would really help you. It will be fascinating in terms of the fun you would have, but even learning a new technique. So I'm learning this also, right? Because it's so new that we are all learning on the fly. But we have like a team of 10 people dedicated to this, trying out different things and selecting the best so that we can put it in a course. And this is going to be very inexpensive. So I hope you support us in the Kickstarter campaign. Thank you so much.
Yeah, me too. Thanks so much, everybody. We will see you next week, same bat time, same bat channel, 9 a.m. Pacific. We hope you will join us. Hopefully things will look a little bit nicer on Zoom then. Thanks again, guests. We will see you next time.
Bye.
Vaya con Dios.
Thank you.
Thank you so much. This was a very fun episode. We hope to see more from the project as time goes on. I think you've got the beginning of something really, really incredible here.
Yeah.
Thank you, Phil. Thank you, Satya.
I mean, projects like this catch attention, right? Last time Paula, she had a very good,
the greenhouse spot.
Over multiple competitions, they actually improved the project so much. It was incredible.
Yeah. All right. We'll see you next week, everybody. Adios.
Okay. Sounds good. Thank you. Bye.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.